Welcome to this explainer on using the Cisco Command Line Interface. Today, we're jumping right into the deep end, straight into the text-based command line environment that real professional network engineers use every single day. We're going to cover exactly what it is, how you access it, and most importantly, what to do when an entire network is relying on you to get it back up and running. If you're just starting your Cisco journey, this is exactly where the theory meets reality.
All right, picture this. It's Monday morning. Suddenly the entire company network goes completely dark. Everything is offline. You try to frantically log in to that shiny graphical user interface to see what's going on, but the GUI is totally inaccessible. The clock is ticking, the business is losing money by the minute, and it is entirely up to you to fix it. So, what do real engineers do when everything else fails?
Well, when those user-friendly apps crash and burn, network engineers turn to the CLI, the Command Line Interface. Now look, this isn't just some archaic technical hurdle you have to memorize. It is literally a direct, unfiltered conversation with the device's operating system, Cisco IOS. When you type a command in here and hit Enter, you're bypassing all those fragile software layers and telling the bare metal exactly what to do. It's the only reliable way to take full control.
Now, if the network is totally down, you obviously can't rely on it to reach your devices, right? You need emergency physical access. Check out the physical console port right here on this Cisco Catalyst switch. You take your laptop, grab a physical console cable, usually that classic light blue rollover cable, plug it directly into this port, and open up a terminal emulator. Boom! You are now physically hardwired straight into the device's brain.
But hey, if the network is up, you definitely don't want to be running down to the freezing cold server room every single time you need to check something. You'll use remote access. But listen, not all remote access is created equal. Telnet, for instance, sends all your data, including your admin passwords, in clear text. Anyone can read it. It is incredibly vulnerable. So the absolute strict standard for any real-world engineering is SSH, or Secure Shell, because it encrypts every single piece of data you send.
Okay, so once you're actually logged in, you really need a solid mental model of how the switch thinks. Cisco IOS operates on a very strict hierarchical mode system. Step 1 is user execute mode. Think of this as a look but don't touch mode. Step 2 is privileged execute mode, which unlocks much deeper diagnostic powers. And step 3 is global configuration mode. This is the big one, where you actually make structural changes that affect the whole device.
Let's actually see this in action. Notice how the prompt starts out as switch with a greater than sign? That means you're sitting in user mode. To elevate your privileges, you type the word enable and hit enter. It's going to ask for a password. If you get it right, watch the prompt. It changes to switch hashtag. That hashtag is your visual confirmation that you've leveled up into privileged EXE mode, or as most of us call it, enable mode. But look, we don't just want to poke around, right? We want to actually build things. So from that hashtag prompt, we type configure terminal. This brilliantly illustrates the shift right into our third tier, global configuration mode. Check out the prompt now, switch config hash. The second you see that config, you know you're in the engine room. This is where the real device engineering happens. Now let me let you in on a little secret. Nobody, not even CCIEs, memorizes the thousands of commands available. We use shortcuts. If you type show and then hit the question mark key, the CLI instantly lists every single parameter you can possibly use next. It's like a built-in cheat sheet. And if you type a partial command, like show IP int, and hit the tab key, the system auto-completes it to interface for you. It is a massive time saver.
All right, let's test your intuition here. Check out this output. We're at the switch prompt, and we try to type reload to reboot the device. But the switch completely rejects it and spits back an unknown command error. Why did this command fail? Take a quick second to think about that mental framework we just established.
Did you catch it? The command completely failed because we were in the wrong mode. Remember, user mode is just for basic monitoring. Rebooting a whole switch is a massive, highly disruptive action. So naturally, reload requires privileged exec mode. Honestly, typing commands in the wrong mode is absolutely the #1 mistake for new engineers. Always check your prompt. Once you are in the right mode, that hashtag prompt, you unlock one of the most important verification commands out there, show running config. This command pulls back the curtain and literally lists the currently active configuration sitting in the switch's RAM right now. It tells you exactly how the device is operating at this precise second.
And here's the kicker. When you actually make changes in global configuration mode,
They happen instantly. If we're in config mode and we type hostname core switch, the effect is immediate. The terminal prompt instantly updates to reflect that new name. You don't have to reboot, you don't have to wait. The switch applies your commands the millisecond you hit enter.
Section 1. The crisis. Fixing the network outage. Let's drop right back into our Monday morning nightmare scenario. Remember? The network is totally down, the GUI is dead, and everyone in the office is staring at you, waiting for a fix. It's time to take everything we just learned and apply it. Step into the shoes of the lead troubleshooter with me right now.
Take a look at a typical enterprise server room. It's basically a massive tangled jungle of cables. If a single switch port goes down in here, there is absolutely no way you can trace the cables by hand to find the fault. It's literally a needle in a haystack. Physical inspection just isn't going to save you today. The command line interface is your only true, precise diagnostic tool.
So you've got your console cable plugged in, you hit enable, and you're sitting at the hashtag prompt. Now what? Your first move should always be the absolute best diagnostic command in networking, show IP interface brief. This command cuts through all the noise and hands you a beautiful, high-level summary of every single interface, its IP address, and its current status.
The terminal is going to spit out a table just like this. And scanning through it, boom, there's our crucial clue. Look at Gigabit Ethernet 0/1. The protocol is down, sure, but look really closely at the status column. It doesn't just say down, it says administratively down. That specific phrase is exactly the smoking gun we need to solve this mystery.
So what exactly does administratively down actually mean? Well, it means the switch didn't just break randomly. A cable didn't magically snap. It means the interface was intentionally disabled by an engineer who literally typed the shutdown configuration command. Yep, it's human error. Someone probably forgot to bring the port back up after a weekend maintenance window. We found the root cause. Now let's fix it.
To fix this, from our global config mode, we need to laser focus on that exact broken port. So we type interface Gigabit Ethernet 0/1. Watch that prompt change one more time to config-if. We have successfully entered the specific interface subconfiguration context, meaning any command we type right now is only going to apply to this one single gigabyte port.
And here comes the final fix. In Cisco IOS, to reverse a shutdown command, you literally just stick the word no in front of it. So you type no shutdown and hit enter. Instantly, the terminal is going to light up with log messages telling you the interface changed state to up. Just like that, traffic starts flowing again. The crisis is over. You literally just saved the entire network using nothing but pure CLI.
Section 2. Pro tips and mental model summary. Honestly, fantastic job navigating that. Resolving an outage like that requires a seriously solid mental framework. You got the network back online, but before you log off and grab that well-deserved coffee, let's quickly lock in these concepts so you can repeat this success every single time.
Now, before I let you go, I want to warn you about a few common CLI traps that catch almost every junior engineer. First, don't try to configure things from the basic privileged mode. You've got to be in config mode. Don't forget your tab key for autocomplete. But the most dangerous trap of all, forgetting to save. If you reboot right now, your no shutdown command gets wiped from RAM entirely. You have to explicitly save your work by typing copy running config startup config. Don't forget it.
So going forward, here is your rock-solid, repeatable mental checklist. Step 1. Connection. Are we totally offline? Grab the console cable. Otherwise, use secure SSH. Step 2. Context. Always look at your prompt to know if you're just viewing things or actively configuring. And step 3. Verification. Always start your troubleshooting with show IP interface brief to get the lay of the land before you do anything else.
Okay, our switch is finally back online, ports are up, data is flowing beautifully. But here's the thought for you. In a massive enterprise, you definitely don't want the accounting department's private data mixing in with the public guest Wi-Fi traffic, right? So how do we logically divide this one single physical switch into separate, fully isolated, secure networks?
Next up, mastering VLANs, switching, and routing. Huge congratulations on surviving your very first CLI crisis today. You've mastered the basic interface, and now you have the tools to actually start engineering the system. Next time, we're going to take these exact same CLI skills and use them to build out virtual LANs, advanced switching, and routing. Keep practicing your commands, keep an eye on those prompts, and I will see you in the next explainer.